Percentages. Percentages. You know, what's the saying? Can't throw a stick at, I don't know what's the saying. You can't take 2 steps out there in the real world and not encounter a percentage. Well, okay, maybe more than 2. If you go into any store, there are discounts, there are sales happening, percentages. You go to the bank, you're trying to save your money, different options there, interest, percentages. Percentages are everywhere. It's not really about teaching percentages, which you will do probably at some point as well. It's more about knowledge that you need in everyday life. That if I'm comparing two products that had a different price, the one sale is a little better than the other one, what is the best one to buy? I need to be able to perform calculations with percentages, which means I need to understand percentages first. And not everyone does. Really, a percentage is simply an attempt to make fractions or proportions more intuitive. That's really why percentages were introduced or made, to have a better feel for a fraction. So instead of saying 1/2, there's a 1/2 sale on an item. It doesn't sound very good, does it? It doesn't sound like a lot either. We say it is 50%. Ooh, 50%, that's a lot. 50 is a lot. But it doesn't change the quantity that I'm trying to represent here. How do I go from one to the other? I'm simply taking a portion of 100. So instead of talking about a fraction of a single whole, I'm talking about a portion of 100. So I'm really scaling everything up so that the fraction is now not sounding so small, but it's going to be a number between 0 and 100. Because instead of talking about a portion of 1, I'm talking about a portion of 100. But the proportion is the same. So fraction of a number, what does this of mean? What's the calculation behind the of? Multiplication. Of means multiplication. And I talk about fractions. Fraction of a number, multiplication. So 1/2 times 100 is clearly 50%. Super easy. So easy. I have example 15.1 there. That I'm just going to squeeze in here. Why not? 3/4 correspond to what percentage? Well, multiplied by 100. What do I get? 75%. 1 1/5. Oh, there's a markup 1 1/5. Doesn't sound very intuitive. Doesn't sound very natural. Multiplied by 100. What do I get? 120. So percentage value larger than 100 means I end up with more. Just like we saw, if I multiply by a mixed number, I'm going to end up with more than one single whole. So a percentage less than 100, and I have less. Percentage larger than 100, and I end up with more. I have the 100%, which is the original, as well as a little more. Original quantity, and a little more. So again, percentages are really just there to feel better about these proportions and fractions. It doesn't change the quantity that's represented underneath. Exercise 15.2. helps us just get used to this, which many of us are, but not everyone. So I cannot assume anything. If I get 25 out of 30 on a test, how much of the test did I get right? 25 30ths of a test. So the test is the whole. That doesn't sound very good, right? Convert it to percentage by multiplying to 100, by multiplying by 100. What do I get? 83.3 repeat. Let's just say we are from now on going to round to 2 decimal places, meaning to the nearest 100. What would it be then? 33, because the next one's a 3, which is smaller than 5, so I keep it the same. So we'll have our blanket statement. We're always rounding to 2 decimal places, meaning to the nearest 100. Then, number 2, if I get 16 out of 22, that's the fraction that I got right of the test. The test is the whole. But it's hard to compare these two. Oh, you got 25 out of 30, I got 16 out of 22. Who's better? It's not obvious sometimes. Multiply by 100 to convert it to a percentage. What do I get?
72.72 repeating, so 73.
So it turns out your test is a little better than mine. So there's another benefit to percentages, which is really why it stayed for that long and we can't be without them now. It's a way to standardize the ratio, the proportions, in that these have different denominators, so it's hard to compare them. But once I look at percentages, it's a portion of 100, always. So it's much easier to compare. I can immediately see which one's better than the other. We say we standardize them for comparison purposes. It's automatically done. And no one's going to question that this is better than this. But here, I need to do some stuff. It's not intuitive. It's not obvious which one's better. Sometimes it's so slight, I can't tell. So percentages percentage has that benefit. Now, pretend you have bonus marks or extra credit or something, and you scored 45 out of 30 on a test, though I don't see how that's possible. What is the percentage? Well, I multiply by 100. What do I get? Anyone? Someone said it really quietly. I just couldn't be sure. 150. Now, the test example isn't very applicable here, but we'll get to a more realistic examples as we go. Any questions on percentages, what they mean, their benefit? There's really no drawback to percentages. It's just making things nicer to get a hold of and get a feel for. Proportions is just making it easier, and that's why it's there. Because fractions are more difficult to compare and work with in general, in your head. You don't get a sense of 16 over 22 as you do 72%. It's just not the same. Though it is the same. It doesn't feel the same. All right. Now, there are different calculations, not many, like 3, when I work with percentages. And I have to be comfortable with the difference between them and what to do in different situations. What are the different calculations? First of all, we take a percentage of a number. Percentage of a number. I'm just going to list them here first. First, percentage of a quantity. Think of interest. I put some money in the bank, I get a percentage of that amount. Percentage of, this is bad form, I shouldn't write this. Write the words. Percentage of a number, a quantity. The other one is, if I increase a quantity by some percentage. Does that ever happen in reality out there? Can you think of an example where that happens? Let me ask you, teacher, why do I have to do percentages? It's lame. They don't use the word lame, they have a much better word these days, whatever. What do you say? Why? Why do I need to do that? Where does that actually happen?
GST? Okay.
Sure. Not sure if Timmy's going to be informed on GST, but yes, absolutely. Or your salary gets increased by a percentage. Your rent gets increased. Timmy doesn't pay rent, it's still.
Loan interest.
Lots. It's just I can't stop if I start coming up with examples. And then decrease as well. Decrease a quantity by a percentage. Really, the relevance of this is, you shouldn't even have to justify, but it's just everywhere. You cannot go without some understanding of percentages. It's just, no. You can get taken advantage of very easily. Decrease a quantity by a percentage? When does that happen? All the time. Black Friday sales. Everything. Decrease. Sales. All the time. Now maybe you have a lot of money and you don't care about sales, but I do not. I need that Black Friday sale. So the relevance is probably more than anything else in this whole course, because you encounter it all the time. Now, we'll do them in steps. We're not doing them all today. A percentage of a quantity. Very simple, as long as I understand what a percentage is trying to represent. It's trying to represent a fraction. So if I have, for example, 25%, no, where's my examples? 75% of 60. Let's write it out first. 75% of 60. 60 whatever, dollars, that. What is this really representing? It's a portion of 100. So it's a fraction with 100 as a denominator. No one wants to say 75 hundredths of 60, so percent is just nicer to talk about. What is the of? Always times. Always multiplication. I've had tutoring where I tell them, how do you convert the of? What is it? Adding, subtracting, multiplication, division. They have no idea. No one tells them this. It's the one word that so directly converts to multiplication. So, this is 60. Look at that. I have it right there. And then I can find the answer. Now, you don't have to do that in your head if you don't want to. Sometimes the percentage is a little strange. You have your calculator. It's all good. Is this a percentage or not?
No.
No. What are the units of this? Whatever this is. Same unit. Could be dollars, could be chickens, could be whatever. Right? It's not a percentage anymore. So that tells me if I have a percentage of a number, it is simply convert the percentage to a fraction, multiplication. That was 1. This is 2 of 15.3. That's some time. 30% of 27. Now you don't have to write all this out every time. Convert it to a fraction of 27. Done. Well, I'm not done, but calculator says nothing. Apparently the calculator says nothing. Well, the calculator, you can ask Siri. Can you ask Siri? Then she actually speaks back to you. We should have talking calculators. I had this idea, not if I was ambitious in any way, I would actually do something, where kids get introduced to calculators earlier and earlier, for whatever reason. Why not make a calculator that you can talk to, and it's not going to give you the answer until you say please? Isn't that a good idea? They want to use the calculator, at least teach them some manners while you're doing it. I think it's a great idea. Who's going to Kickstarter? I don't know. Where's the answer?
8.1.
8.1? We don't have the units there. We don't know if it's dollars or whatever. So it is what it is. The one thing I do not want to do for the love of everything you hold dear, do not ever use the percentage button on your calculator. Don't do it. Ever. Ever. What does that percentage button do? Some people do 27 times 30 percentage button. What does that do? Exactly. Divides by 100. Because that's what's missing here, right? But if you teach that percentage button, there's no understanding of what a percentage is doing. You'll get the answer, but it means totally zero. Don't do it. There's no insight. There's nothing. You cannot type divide by 100. We're that lazy? No. Don't touch that button ever. Ever. Take a little Sharpie, black it out. Not on your phone. And run it. On the $11 one. 120% of $14 or whatever. Last one. Same, it doesn't matter what the percentage is. 120 over 100 times 14. What do I get? 16.8. Percentage of a number. It's not hard. The other two are very similar. The first one is if I increase quantity by a percentage. So, for example, my salary gets increased by 10%. What is the new salary? What is the calculation behind that, and what is a most efficient way of writing that calculation? So let's do it by example. Let's say, I don't know what the book does. I do have it. Let's say I have $1,000. Well, maybe you. Someone. And it gets increased by, let's make it simple, 10%. What is the calculation to find the new larger, because I'm increasing it, quantity? So the new amount is going to be the original 1,000. I'm going to leave the dollar signs to not confuse us. Plus, I'll say it informally first, 10% of 1,000. Because when I'm increasing my amount by a percentage, I have the original and I get a little extra. Now, this is in quotation marks because it's not a calculation, but I can convert it to one by saying the fraction version of the percentage, which is the percentage value over 100. Of is multiplication, and I'll put it in brackets, just because I want to group them together. Though BEDMAS tells me I don't need the brackets. I'm also going to emphasize here that I have 1 times my original amount. I have my 1,000, and I'm adding a little bit to it. Now, in this case, decimals, I feel a little bit nicer, actually. So, in place of this, we can write the decimal version of the fraction. And I'll emphasize the second decimal, because sometimes it won't be a 0. So what do I have? So my new amount is 1 times 1,000 plus 0.1, or just 1 0, times 1,000. So think of it with apples, or think of it in any intuitive way you want. I have 1 1,000 and another 0.1 1,000. How many 1,000s do I have? 1.1 1,000s. Now I'm going to write the 0. Where do these come from? The 1 comes from this one, comes from this one, comes from my original amount still being there. The 0.10 or 0.10, if you will, temporarily say it like that, comes from this, which comes from this, which comes from this percentage. This percentage. So it's as simple as saying, well, I'm going to multiply, I'm going to scale my original amount up because it's an increase, meaning I have my original, but a little more than 1. How much more? That percentage more, that gets positioned in the decimal positions. I think by example that's simple enough. So if I want to just make space here, if I have another example and I say I increase, let's say $2,000 by 5%. Not what is the amount, the new amount. How do I find the new amount? How comes first? What? A monkey can put it in the calculator. That's not the challenge. How do I set up the calculation? My new amount is, by this argument, something times 2,000. I'm scaling it up because I'm increasing it. So I have the 1, which is my original amount. I'm just getting more. How much more? The percentage gets positioned right there, and in this case, it's a 0.5. And then put it in your calculator, see what it is. I don't care what it is. I care how to find it. Does that make sense? The decimal numbers are a little more convenient, I feel, in the case where we're increasing a percentage, though they are just fractions. Any questions on that setup of that calculation? Some of you may already know this, some of you don't. That's why I'm doing it. Any questions at all? So when we get to our word problems, it'll be these calculations all over the place when I'm translating the words into the calculation. And whenever I'm increasing by a percentage, it's going to be 1 point something. And that something comes from the percentage. The other one is decrease a quantity by a percentage. When does that happen? Maybe there's a sale, a product is marked down, Black Friday sales, happening all over the place. Good times. Not for my wallet, but good times for getting stuff. So let's do a very similar example and say I have $1,000 and I'm decreasing it by 10%. It's nice in the beginning to just take familiar, comfortable numbers like 1,000, 10. Though it doesn't matter what they are. What is my new amount? Not what, how do I find it? My new amount is an adjustment of my original amount. So I have my 1,000, but now I'm decreasing, so I'm taking away. I'm taking away 10% of that amount. So I'll write it in quotations first, 10% of 1,000. Well, percentage of a number is the fraction version times the number. That is a very weird zero there. Yeah. Now the fraction's not as nice to work with, so we're going to instead look at the decimal version. The brackets just help me focus on the sections of the calculation. I have one of my original amount. So my new amount, I have 1. I take away 0.1. How much do I have left? 0.9. I'll write 0.90. So in the increase case, I'm going up from 1. In the decrease case, I'm going down from 1. I have 1, but less. How much less? This much less. So this is 1, because that's my original, minus the decimal version of the percentage. So increasing, decreasing, up and down from 1. Up and down from my original amount. If I squeeze in here a little second example, I'm decreasing $2,000 by 5%. That's not a big sale, but it is a sale. It is a discount. What is the calculation? Notice here that I don't calculate any answers, because that's not the challenge. The challenge is setting it up. Yes?
Is it supposed to be 1,000 instead of 1,000?
It totally is supposed to be 1,000. Yes. What does the calculation look like? Well, decreasing tells me I'm going down from 1 by how much? By the decimal version of that percentage, which is 0.05. So it would be 0.95 times the original amount. That is my new amount. And it really is. That's as simple as that. Once you get used to it, those calculations, those 3 calculations, just appear over and over in combination, and all kinds of things we can do with that. Any questions on these 3 calculations? Familiar? Medium? Not familiar at all? All of the above. Everyone's different. Everyone's experiences are different. So in the book I have it more general. Instead of taking a specific number, I use the n to represent any number. But it doesn't matter. If you're more comfortable with actual numbers like 1,000 and 2,000, that could be used to get to the calculation. Now it is a matter of doing some problems over and over and over and over and over and over and over. Because the only way to get better at word problems is to do more word problems. There is really no shortcut to experience. All right. Oh, I didn't erase that very well. So So we're looking at exercise 15.4. In a store, there is a coat. Sounds obvious. That was originally $120. During a sale, it costs only $90. What is the percentage discount? Now, what is the most intuitive way to go about this? It's really a question like the 15.2 questions, scoring a certain amount out of a test. So, the discount or the decrease amount, or whatever you want to call it, is $30. 120 minus 90 gives me 30. So what the question is really asking is, what percentage is 30 of my original? Let's ask that question. Let's write it down. What percentage is $30 of my original? Of course, it's always relative to the original, and the original amount was 120, not 90. 90 is the new amount. So they're giving me the original and the new. Clearly it was a decrease of what? Well, 30, but what's the percentage? Well, percentage of a number, that is going to be, well, let's say here, the percentage is, I scored 30 in a test out of 120. It's exactly the same. How do I convert this to a percentage? Multiply by 100, because it's a fraction of 100. What do I get? Nothing? I get nothing? I think it's something.
25.
You don't have to do it in your head if you don't like that. It's totally fine. Calculator's your friend here. 25%. So going from 120 to 90 is a decrease of 25%, or a discount, or whatever. We can check it. As a side note, that if I decrease $120 by 25%, then the new amount, if we did everything correctly, should be 90, but we have a calculation for how to decrease by a percentage. So it's my original, whoops, sorry. The decimal version is 1 minus the decimal version of 25, so it's 0.25. So it's 0.75 times 120. Do I get 90? It's not really the emphatic yes I was hoping for, but I do. So it's time to get busy with some calculations now. Yes?
For that equation at the top, would it be 120 minus 30 since you get $30 off of the item?
They're looking for what percentage is that discount amount. So what is the discount amount? The change is 30.
Oh, so
What
it's
percentage
like
is
the
that?
calculation is what you saved?
How much did I save?
Okay.
Yes, yes. Relative to the original. Of course, there's a lot of variations on the wording, and that makes word problems difficult, because there's so many words you can use, but they all mean very similar things. And really only by seeing all kinds of different phrasings and things, ways of saying things, does it get easier. So in many ways, math is very simple. There's only one way, there's only one calculation. But there are so many words to get to that calculation. Any other questions or comments? This is just our first example. Maybe not the simplest one, but I have to start somewhere. 15.5. Let's read it and then I'll make space on the board while you think about it. In another store, a coat is reduced by $20 to a sale price of $100. What is the percentage discount? Or what percentage did you save? Or many words you can use to ask the same question. Let us see. So now in 15.5, they give me the discount amount. The amount that I'm saving is $20. They give me the end result. The new price after the decrease is 100. What is the percentage discount? Is it just 20 over 100? No, because it's relative to the original. It's a percentage, a portion of the original. So that means I have to find the original amount. It's always relative to the original amount. What is the original amount?
120.
I'll make it absolutely clear here. That it's the new plus the savings, which is my original 120. It happens to be the same, but same original amount. So what are they asking? What is the percentage discount? So it's 20 over 120. So the percentage saved or discount or whatever word you want to use is therefore 20 over 120, and I convert it to a percentage. Whenever I have repeating decimals, round to 2 decimal places, round to the nearest 100. 100. What do I get? 16.67. I want to get used to, even in these small, very simple half-word problems, they're not a full word problem, to write a concluding sentence, even though I've used words here, to say what is my answer, what are the units of my answer number, all of that. So this is still calculation, and the words are somewhat optional, just helps the reader follow it. My concluding sentence is going to use the words the question uses, the percentage discount, which I happen to use there as well, but a full, nice sentence. The percentage discount is 16.67, and then I say percent. You can say it here too. Just a nice, grammatically more correct sentence. Earlier, the words were just there to keep track of what I'm doing, say roughly what I'm doing. A nice sentence to wrap up my word problem is a good habit I want to get into as early as possible, even in these questions. Any questions on that? It's just variations, the same thing. I'm trying to get used to different phrasings and different things around percentages. Very good skill to have for everyone. Next exercise, 15.6. In a certain area, city A's population is 15,000 and city B's population is 12,000. Hardly a city. Anyway, then a couple of questions. City A is what percentage larger than city B? And then some other questions as well. And this exercise tries to get me to realize that a percentage is not anything on its own. On its own, it doesn't mean anything. Just like a fraction doesn't mean anything. It's a fraction of something. It's a portion of something. Okay, so the wording there might be a little strange, but it is what it is. City A is what percentage larger than B? What do I do? Turn the camera would be a good idea. Something I struggle with. There are multiple ways you could do this. You could look at the difference. The difference isn't going to change. So the difference is 3,000. That's not going to change. Think of it as a quote with a price change, a sale, things like that. The idea is the same. City A is larger. How much larger than B? So relative to which city am I looking? What is my answer going to be eventually? What is the sentence going to be that's my answer concluding sentence? City A is some percentage larger than B. That's eventually the sentence I'm looking to write down. It's going to be relative to B.
So does it have to be over 100%?
No, I'm making my fraction, and then I convert it to a percentage. So what is the fraction when it's relative to B? Well, it's 3,000 over, what's B? 12,000. Everyone happy with that interpretation? Apart from the screaming outside, they're really happy it's Thursday, I guess. It does feel like Friday. I don't know why. Wishful thinking. All right. So now, how do we make that a percentage? Multiplied by 100. So this is my calculation, my scribbles. It's a very small calculation, really. So the concluding sentence is really what we need here. What is the percentage there? Is that a nice... That's a nice number. What is it? 25%. And I can put that in here. 25%. I want to show the alternative way of doing it, and you can decide. There's no right or wrong one. They're both equally valid, really. Squeeze it in here, I guess. Move this sentence a little too far down. What we could also do is look at city, which one's the bigger one? A, relative to city B. So look at it that way. That would be 15,000 over 12,000. Let's make that a percentage. What do I get? 125%. So there are different ways of talking about this. We could say that city A is 25% larger than B. We could say that city A's population is a 25% increase of B's population, or on B. We could say city A is 125% of city B in terms of population. But because the 100 refers to the original, the increase there is 25%. So I don't need to have 25 as my answer. I can look at it in different ways, and because I understand percentages, I can interpret this 125 and say it's an increase of 25% on top of the 100 that was my original. So there are many different ways of phrasing it. Let's write down some of them. City A is 25% larger. I wrote this sentence because that was the closest to the question sentence. We could also say, what did I say here? City A, in terms of population, is a 25% increase. What's the word here? On B? Of B? Of? I don't know. I do math for a reason. On sounds okay too. Or you can say here that city A is 125%, of course in population, of city B. All of them mean the same thing. All of them imply a 25% increase, but they're phrased differently. And I have to be comfortable with all of them. But the one thing that this relies on is what city is this change relative to? In this case, it's B. That might be the only challenging part. All right, number 2. City B is what percentage smaller than A? Now it's relative to what? It's relative to A. It's not easy. It's a little bit of intuition and experience there. Think of the second one as the one that it's relative to. In all my sentences here, the second one is always B. Now the second one is A. So it's a change relative to A, relative to the second one. It's a change of something. Pay attention here. City B is what percentage smaller than A. Now, which one of these do you like? I don't really know. You should be able to do both. I don't know. This one then? First one? So, the fraction that I'm setting up to answer this and then converting is 1. Smaller from A, and A is 15,000. So it is the change amount over the original. It's a little less intuitive because it's not like one city changes into another one. But we have to have something that the change is relative to in terms of how I phrase it. So I change that to a percentage. What do I get? 20. So many different ways of saying it. It's always good to check. Am I answering the question here? B, what percentage smaller than A? So I can say many sentences. I can say city B is 20% smaller than A. And that phrasing, the second thing is what it's relative to. So there's some consistency in what we're saying here. And I'd like my concluding sentence to sort of resemble the wording of the question sentence. Any questions on that? Not everyone is equally comfortable or familiar with percentages, especially how we talk about percentages. Very important. You can very easily talk about a percentage in the wrong way. Even though you know what you mean, it's not actually what you're saying. Number 3. City A's population is what percentage of B? Oh, we answered that already, didn't we? 125. Oops. I'm just that efficient. So we'll skip that because I had it right there. I can answer it again if you want to, but I'm not going to. City B's population is what percentage of A? So B relative to A. Not the change, not larger, smaller, just the amount. So the fraction that I set up is what? B relative to A. Convert it to a percentage and I get 80%. Just be careful, you can totally say 0.8, but if it's asking for a percentage, you have to say 80. If you're using that percentage, I'm converting it to a decimal. They'll become obvious as we go. So I check my sentence, my question sentence, city B's population, what percentage of A, and I answer it accordingly. City B is 80% of city A. That's a very important point that I should make maybe early so you can think about it. When I present an answer, there the percentage is. When I'm performing a calculation, there should not be a percentage anywhere in the calculation. If I'm using this for some reason, let's say there's a follow-up question or whatever, and I'm using this 80%, I'm going to use the decimal version. I see people in some parts of the world using the percentage in the calculation. It's just sloppy, it's not clear. Because whenever there's a percentage sign, it implies division by 100. If you want to divide by 100, divide by 100. Don't make it hide behind a symbol. It's not right. It's not right. But we'll get to those fancier questions as we go. Just keep that in mind. Presentation, percentage. That's what it's there for presentation purposes, not for calculation purposes. Alrighty, I include 15.7. It's not super important. It's not a test question. But it is something to keep in mind when you're out there, you don't have your phone handy, or you want to quickly calculate a percentage or something. What do? You can't calculate it accurately. Well, maybe you can, right? It's nice to think of familiar fractions that are close to the percentage and use those to easily perform the arithmetic, perhaps. So, I'm not going to write down too much here because it says mentally estimate, so that means no writing down. 15.7. I'll give you an idea and then we'll talk about what is the fraction closest to 35%. If I'm calculating 35% of, what was it? Doesn't really matter. 121. That's not my calculation, that's a sentence. That corresponds to, I'm now not going to use a decimal because decimals aren't necessarily as intuitive to me as fractions in calculation. That's the calculation, right? Who can do that in their head quickly? I have no shame in admitting, not me. But it's close to familiar numbers. This is close to 120. And this is close to 33.33%, which is what simple fraction? 1/3. Now I can take 1/3 of 120 in my head very easily. What is 1/3 of 120? 40. Now the answer isn't 40. We say it's approximately 40. But it's pretty close. Let's calculate this. What is this exactly? Just out of curiosity. I don't know how close close is. Close is relative, right? How close is close? 42.35. 42? That perceived as close. And for the speed that I'm getting as a bonus, that's going to be close enough. So those are good things to keep in mind to make calculations easier so that you can do them faster in your head. Out there, you're looking at two products. One is on sale. The other one comes in a larger package. What do? I can't use their numbers. It's too hard. Yes?
I was just going to make a point about this because I work as a server part-time, and people are so bad without a percentage option, like calculating percentage.
Do I have a 15% there?
Yeah, like 15%, you just take 10% and then half of the 10% and add it together, and people can't figure it out.
If you do all this and you go out there and you really pay attention, Yeah, it's pretty bad. For some reason, that one didn't occur to me until someone said it. I did 15% as a half of 30, so a half of a third, which only plays in your favor because I actually give you like 18%, but still. No, 16, but still. There are many ways of doing it, but people don't really think about it. It's kind of sad. Yeah, we don't want to be that reliant on technology. You know, it's nice. And little Timmy's going to tell you one day, hey, teacher, why do I need to do this in my head? I'll have my phone with me. You can just do it on my phone. Why would I need to do anything else? That's a hard question. Because whatever you say, he's not going to be happy with it. Unless you say, you're right, Timmy, you can just use your phone. Let's go for recess. It's hard. It's hard to justify why we need to practice these things. Anyway, that's the question for you to decide on your own. 52%. I'm just going to do like a couple of these and then we'll just run through them very quickly since I'm not going to ask this in a test, but it's a good life skill for sure. This would accurately correspond to the calculation 52 over 100 times 12, but that is so close to a half, and 12 is totally fine. Leave 12 and get 6. Easy. I know it's not exactly 6, but you very rarely need the exact number. And say, oh, it's approximately 6. So many times I've been asked, just casually, for whatever reason, oh, what is this times this? I don't know, but I can round the numbers to something easy and then say, oh, it's approximately this. And it's just, I don't know, it just didn't feel right for me to say, hold on, let me get my phone, I don't know on me, I'll go look for my phone, and then I can find the answer for you. No. Okay, let's talk about the others. 65% of 67. What would you do? What's close to 65%? It's fraction. 2/3 is close. Then you can decide how easy is 67. Can I make it 70? Do I need to make it 70? It's up to you. Right? You get people that are really good and will tell you exactly what 65% of 67 is. It depends how fast you want to do it. 15% of $39.15. That's a pretty standard tip, I guess. Though your potential lack of arithmetic skill could play in your favor because 20% would be easier to calculate. So I would be like, yeah, screw it, I'll just do 20%.
Or some people just do 10.
Oh,
That's
so
easier.
that does not play in your favor, yeah. 10% is easier. So 15%, like she said, make it a 40. Make it $40. No need to worry about those cents. And then take 10%, which is so easy, 4, and add half of that to get 6. And you're pretty close. And because I rounded up, I give you a little more. 23% of 102. What would you do with 23? You can go one of two ways. You can go to 20%, you can go to 25%. 25 will be a little bit closer, and 25% corresponds to what fraction? 1/4. And then make it 100 instead of 102. And it's not hard to do at all. 35% of 66. 35. That's close enough to a third. And then you can decide, am I good with 66? Well, then actually it's going to be a very nice division by 3, so I would leave 66. So it depends. 76% of 399. What would you do? See, the nice thing here about estimation, which I used to tell kids, is there is no wrong answer. Because they don't say how accurate you should be. So whatever my answer is, you didn't say it should be more accurate, so it's accurate enough. You can't be wrong with guessing. That's the beauty of it. Sorry, what did you say?
75%.
75%. That's 3/4. Make it a 400. Not hard to do. What percentage of 402 is 66? What would I do? Not what the answer is. What would I do to speed up that calculation and then sacrifice some accuracy? A fraction of 402, well, I'll make it a 400. And then you can decide, do you want a 60 maybe? Or 60 is a little far away, but it'll add some speed. So what fraction of 400 is 60, 65, whatever's easiest for you. Just that 60 something over 400. 74 miles is what percentage of 298 miles? Who knows? If you give me like a few minutes, I can probably do it. But in my head, it's going to take a while. Make it easy numbers. Make it a 75. Make it a 300. And it's much more doable. That's the only point I'm trying to make here. Don't be intimidated by these things. All the answers out there can be approximations. And you can round up or down depending which side you want to favor. 24 pounds is 49% of what? Well, make that a 50. 24 pounds is 50% of what? 48. That's not hard at all. But 49? Whew. That is much more difficult to do in your head. So I leave that in to just make a point, because it's not something we always think about, but it's something we shouldn't be shying away from or be dependent on our calculations. And then if we need to be accurate, sure, a calculator is there to help us, to make things more efficient. But don't be lacking basic skill. It's not right. Plus you're leading by example. And if you have a little practical scenario in class, and the question of 23% of 102 miles comes up, if you can't do it, or at least show some confidence in estimating that, the kids are going to bounce on that and not want to do anything. You have to lead by example. You don't have to be accurate, but at least do that estimation with confidence.